चलो
My name is Mozam Arslan and I am the student of BS Physics. I will start the topic of ionization energy and give the explanation about it. First of all, we know that ionization energy definition. There are two kinds of two definitions of ionization energy. I will describe you. Ionization energy. थोड़ा सा नीचे. Ionization energy and is the energy to remove an electron from a gaseous atom. If we have an electron in the outermost shell of an atom, the energy to remove an electron from the outermost shell is called ionization energy. And it is positive ionization energy. The second definition of ionization energy is also the energy required to remove 1 mole of electrons from one isolated gaseous atom. Ionization energy is the energy to require an electron from the last orbital of an atom. उसके बाद we have many examples of ionization energy. For example, if we have an element of periodic table which is magnesium, we will describe the magnesium ionization energy. If we remove an electron from last orbital of magnesium, the energy ionization energy which is absorbed is 736 kilojoule per mole. Ionization उसके बाद है magnesium कि if we remove the electron from magnesium, the second ionization energy is 1445 kilojoule per mole. Last time ionization energy in third time ionization energy is 730 kilojoule per mole. Similarly, if we write the ionization energy 4 time of magnesium, it increases and its number goes on increases. We have we have trends of ionization energy in the periodic table. I discuss it. Ionization energy has trends in the groups and periods of the periodic table. Ionization energy from left to right in a period increases because atomic radius decreases. If the atomic radius decreases, the electrons because if the atomic radius decreases, the electrons are more attracted to the nucleus. Then the ionization energy increases and ionization energy increases and atomic radius decreases. If atomic radius increases, then the shape of the orbital goes on increases and ionization energy decreases. Ionization energy and atomic radius both are inversely proportional to each other. Similarly, if atomic radius decreases, ionization increases and vice versa. So in a period, the atomic radius the ionization energy increases. Due to this, the force of attraction between nucleus and valence shell electron also increases. So force of attraction and ionization energy both are directly proportional to each other and they have same result. Similarly, if we discuss the ionization energy trends in a group, then it is opposite to each other. Ionization energy in a group, if we discuss the trends of ionization energy, then in group the atomic radius increases. As a result, the ionization energy decreases. The atomic radius, due to this, the shape of the shell goes on increases. The size of the shell goes on increases. The force of attraction between nucleus and valence shell electron decreases. Due to this, the electrons move away from the nucleus and the distance between the nucleus and valence shell electron increases, and shielding effect also increases. So due to this, the ionization energy decreases. Ionization energy decreases, so atomic radius and ionization energy are inversely proportional to each other. We have also the graph of ionization energy. This can be discussed from this. In hydrogen, ionization energy is low, but as the graph moves upward, helium, the ionization energy decreases. This phenomenon goes on until at the end of the periodic table. But lithium has low ionization energy, but beryllium has highest ionization energy. But beryllium has high ionization energy, but boron has low ionization energy. The graph is for the whole periodic table, and same principle is applied. Ionization energy is always positive due to some reasons. The reasons are that ionization is positive since every electron is bound and thus has negative energy. Due to negative energy, ionization energy is positive, and in the process of ionization, energy is always absorbed, not evolved. Ionization energy is different from the ionization energy is different for the different elements, and its value goes on increasing, and its value goes on changing from for every element. For example, if we discuss the values of ionization energy, here are some. If the ionization energy of hydrogen is 73, but for lithium it is 58. The different elements have different values of ionization energy. In the periodic table, we discuss the ionization energy of every element, but in short, every element has different ionization energy. Ionization energy has many effect in the periodic table. Due to this, it is directly proportional to force of attraction of between nucleus and valence shell electron. If there is no ionization energy, the force of electron between nucleus and valence shell electron decreases, so electrons will not move closer to the nucleus, and as a result the ionization energy will decrease. Ionization energy is the also we can also describe that ionization due to ionization energy, the electrons and nucleus came closer to each other, and the electrons and the nucleus came closer to each other, and the distance between them decreases. Due to distance, shielding effect also decreases. And atomic radius, due to increase in atomic radius, ionization energy decreases. Due to this, this principle is applied in whole periodic table except for some elements, and ionization energy is the phenomenon which is applied throughout the periodic table. Due to this, every elements have chemical properties, since every ionization energy of every element is different.